we are far more aware of the environmental consequences of our actions than we were a few years back.
Energy efficient, sustainable buildings are much better than traditional ones.
Technologies keep evolving. Wind power, which you traditionally see deployed over large farmlands or lakes, is now coming to the point where you can employ smaller units on top of buildings. So we're hoping to be able to use wind power on some of our projects in the future.
The energy modeling gives you the power to provide option to the client.
We have invested heavily in technology platforms to do energy modeling, to evaluate all of our projects for looking at ways to improve our projects and its footprint on the environment. And we're continuing to create innovation centers where our youngest staff that have these tools coming out of university become one of our biggest assets and our biggest advocates for introducing these ideas that we can put into practice as we continue down the road to carbon neutrality.
Embodied carbon became as important and now even more important, as in more impactful of the environment as operational carbon. So what do we do about that? We obviously want to reduce that embodied carbon. To do that, there are many strategies. We have to be selective of the material, and then we also have to be selective of the systems that are used in those structures.
The three main strategies we use to reduce our carbon footprint are the electrification of buildings, the use of enhanced dimming controls, and the use of photovoltaic cells coupled with on-site battery storage. We have the ability to electrify not just new buildings, but both existing buildings, and something that we've done a lot of is the electrification of heritage buildings, which requires extra care in protecting the heritage fabric of anything that we need to do.
We develop for us and for the client three main strategies or proposed options. We label as a green, greener, and greenest.
Embodied carbon is basically the amount of carbon that is expended as we build our buildings. For the longest time, people have been focused on operational carbon. Operational carbon is basically the amount of carbon that is expended in running buildings.
In our world, in the mechanical engineering, we use multiple tools for energy modeling. We also rely on our sister building science, Scion. They provide for us a lot of testings. One of them is the blower door test.
So whole building blower door testing involves pressurizing a building, either negatively or positively, using a fan built into a door frame, essentially. So you're introducing or vacuuming air out of the building to create a difference in pressure between the exterior and the interior. And with that, you can determine how much air leakage is happening in the building, or like how much air is exchanged between the interior and exterior, and sometimes the locations. So what are the problem areas?
The biggest challenge is to change the perception.
Our choices, our knowledge, our methods matter.